Hi, my name's Emily. I'm here with Eric at our annual conference, ICE. We appreciate our friends over at RTI. We appreciate your support of the HTM community with special trade-in programs and training. Why don't you go ahead and introduce yourself?
Well, my name is Eric Wickström. I'm the training manager at RTI. I'm based in our global headquarters in Sweden, joining colleagues here in the US who work out of an office in New Jersey, where we've got both the sales office, service center, as well as a calibration lab for all the equipment that we have here.
Wow, so quite the trip.
It is, yes.
Yes. Can you share some highlights of RTI's X-ray test solutions for CT, mammo, RADF, and even dental?
Yeah, sure. Well, we've got a range of products, and what I'd like to start with and just is have a look at the first one, the flagship, which is the Piranha. The Piranha is a multi-modality instrument. This one I'm showing is a Piranha Multi. It does everything from mammo, RF, CT, dental, all in the one unit.
Wow.
The detector area is this white area here, and from there you can get KV, dose, time, total filtration, and HVL all in the one shot.
Wow, technology is amazing. It's so compact, but it does all that.
It is quite compact.
Yeah.
And it does a decent job as well.
Yeah, absolutely.
And, as you see, you have a blue light here. That indicates that it's Bluetooth ready. So most of our customers use that Bluetooth connection instead of running wires back into the control room and to their console where they actually do their testing. If there are difficult conditions, there is a possibility of running a USB cable as well from this port right there.
Wow.
So you have the two options, but the Bluetooth option is the most popular.
That's incredible.
Yeah. This is the base unit. So we put this in the beam, in the X-ray beam, and we pick up those, the KV, the dose, total filtration, and all that. For certain applications, we have an extra port right there, which connects different probes. So we have a collection of probes. We have an external dose probe, looks like this. It's 10 by 10 square millimeters, so it's also quite sensitive, 100 square millimeters. We have a smaller one, which is useful in fluoro situations, where you have a small footprint to measure the dose, so you don't affect the AEC too much. There's a carbon fiber rod to allow it to move it around and position it in a good position. So that's quite popular as well. For other modalities, CT for instance, of course we do have a CTDI ion chamber. Looks like this, it's a standard size, 100 millimeter, that fits into a standard Phantom. It's powered, gets its bias voltage by a chamber adapter.
Wow.
So it connects to the chamber adapter to get the bias voltage, and the chamber adapter connects back into the Piranha, like so.
Okay.
So it will fit on the CT couch. This would be in the Phantom, this would be on the couch, this would be on the couch, and there would be a Bluetooth connection over to your laptop.
That makes a lot of sense.
In the console.
Wow.
And so continuing with CT, we've got a CT dose profiler. Looks like this. Looks like a pencil ion chamber, but it's actually solid state.
Okay.
So it has a built-in point dose detector right here. That actually then it's 0.25 millimeters long, so that makes it a point dose detector. The idea is there that if you move it through the beam at a known speed, and you know the sampling rate, we can recreate the dose profile.
Okay.
So thereby getting the beam width with an accuracy and a reproducibility of down to fractions of a millimeter.
Wow.
That's kind of interesting.
It's incredible.
So it makes it, with one scan, you get the beam width, the full width half maximum, very accurately.
Absolutely.
You can also use it in a Phantom. Center hole, make one exposure, because we've collected empirical data that gives us the ratio between the dose in the center hole and the peripheral holes of the Phantom, so that by measuring it in one position, we can then calculate all the CTDI weighted in one exposure.
Wow.
So that makes for quite a lot of time saving.
Yeah.
Instead of making minimum five, usually you'll have some triggering issues, so you may need to do some more. but with the seed-to-dose profile, you do one, and you're good to go.
Yeah, and time saving is so important.
It is too, and accuracy and reproducibility also.
Exactly.
That's becoming more and more important. What we have understood. And then moving on, we've got some other stuff. We've got a light probe for measuring the monitor light. It also converts into an ambient light meter. The very same principle there. This goes into the Piranha, and that measurement goes back Bluetooth to wherever you are with your laptop.
Wow.
For MAS measurements, we've got an invasive, like everybody else, where these cables go into the generator, where you pull out the jumper in the generator. There's a cable here that connects to the Piranha. So you get the MA and all the kV, the output values, kV, dose, etc. And you also, with the same exposure, can get the MA waveform out of it.
Oh.
So that's the invasive. Most of our in the industry have that as well.
Yes.
So what we also offer is a MAS 2, which is a clamp-on version of doing it. So it actually clamps on to the high tension cable by the tube. We connect the wire here to the Piranha, put the Piranha in the beam. So in the one exposure, you just get the MA, MS, KV, dose, total filtration, and HVL, of course.
Okay.
All in one shot, superimposed.
Makes sense.
Yeah. And the most difficult thing when you're using this one is to attach it the right way. This way or this way around. So that's the most difficult trick or the difficulty to overcome with the MAS 2 probe. So it's quite popular for troubleshooting for biomed, for instance, and for service staff for the first troubleshooting and the first tests that they do. Don't have to dig into the generator, just clamp it on. It's fast, easy, and safe.
Got it.
And
last but not least,
in the family, we have the cobia, which is actually one of a family of cobias. What we're showing here is the cobia flex, which is the top of the line there. As you see, the big difference to the Piranha, it's got a display which shows the KV, the dose rate, total filtration, and HVL, and time all in one. So when you make an exposure, the data will be collected, and the values will scroll through in a predetermined number of times.
Okay.
And the idea, you see, the display is quite large.
Yes.
Yeah.
And clear.
And clear, and the idea is that it should be visible at a distance of 15 feet, which is typically the distance from the console to the couch where you're at. So you should be able to have a look and see and be able to note down the figures.
Okay.
Some of these models also have Bluetooth, are fitted with Bluetooth, so then you wouldn't need the display, you get the Bluetooth.
Got it.
The information from the software that we'll look at in a while. You'll see that on your laptop instead.
Okay.
So this Cobia Flex also has a port, the same port as the Piranha has, to which we can attach all of these probes.
Okay.
Yeah.
Fantastic.
So yeah.
Now, if I'm not mistaken, I want to say you guys recently had a product launch. Do you want to go into a little bit more detail on that?
Well, yes, we did. We launched an additional probe to our program. This is then related mostly historically with the output of the tube. And we launched a scatter probe a while ago, which is designed for leakage measurement and scatter measurements in the X-ray field.
Okay.
So it has a range of 10 keV up to 150 keV, which is then the mean energy of the spectrum that we measure.
Okay.
So it makes it suitable for leakage and scatter measurements from mammo all the way up through to CT and even some higher measurements there.
Okay.
When it comes to scatter. The interesting thing here is that, as you can see, we've got it marked, the active area here is regulation size. It's 100 square centimeters. And that's the size called for in regulation by the IEC as well as FDA.
Okay.
So it fits that, and you can make those leakage and scatter measurements with just one exposure.
Absolutely.
So not only the leakage, but also the barrier testing, where you need a 10 square centimeter size area to cover. So it's kind of good. It comes with this mini tripod, converts to a handle if that needs if you need to. But if you have another tripod, is just a tripod,
Yeah.
normal camera tripod thread that fits into it.
That's amazing.
Yeah, this one is wired.
Okay.
So it's standard, but it's not wired to the Piranha. It's wired directly to your laptop, to your PC.
Oh.
So there's a USB cable from here to your laptop, and that's where you collect the data.
Okay.
So we're quite thrilled. We've designed it and developed
Yeah.
it together with some of our largest manufacturers in the industry, and the feedback that we get is interesting. Not only because it's regulation size, but the sensitivity is enormous. So
Oh, really?
It is, yes, ridiculously sensitive. So that makes it an interesting tool
Yeah.
for that segment.
Now, my next question, with everything here, is this all that we would need for a complete set of X-ray test tools?
Well, this is a big start. I mean, what you see is quite a big range for whoever's going to do some testing in this field. But we also then offer holders to position the probes in the right position that are specific for each manufacturer, so that we position the probes in a reference height, for instance, or a reference position horizontally, so that we can actually help so that the engineers will be able to do a calibration the way they're supposed to be. Then we also have some other tools to measure the beam and light field alignment, and yeah, those kind of things. So we offer quite a large selection of tools, and one of the larger in the industry, to help biomeds as well as physicists and engineers to perform their job in a better way.
Absolutely, and as you know, the more recent advancements in the industry have been driven by software. My question is, how is RTI addressing software to create time savings, traceability, etc.?
Well, it's the reason that we've developed since many years back the software package we call Ocean Next.
Yes.
And we'll have a look at that, and I'll explain some more about that.
Okay. All right, guys, so we went ahead and moved. Eric and I are standing up here with Ocean Next. Will you go into a little bit of detail and tell me a little more about it?
Yeah, sure. It's the Ocean software. It's the latest generation of the Ocean software. We call it Ocean Next. Ocean has been on the market since 2010, and this is the fourth generation of that software. So
Okay.
slowly moving to more and more functionality in it. And what we have here is a software package. You can say that it's divided up into three major parts.
Okay.
Where we've got a quick check, which is then the instrument part of it, which makes the Piranha a complete instrument. Just so you get the values, the data from the instrument. Then we've got something we call templates that we work with, which indicates that it's a potential time-saving tool for whoever is using it. And then we've got the possibility of saving all the data in a database and using that for traceability and for quality control in the long run. So the first one we'll have a look at is the quick check,
Okay.
which is a little bit kind of a plug-and-play functionality that the software will then communicate with whatever instrument we have attached. And depending on the configuration of that instrument, it will ask questions. What do you want to do now? And what we have attached now is a Piranha Multi, which can do radiography, fluoro, mammo, CT, and dental. So we need to decide which configuration we'd like to have. So say we want to try radiography. The software will then configure itself and pull up a view that gives us as much information as we can.
Okay.
So like I told you before there, we have from the Piranha the KV, time, dose rate, total filtration, and HVL all in one shot.
Okay.
And these values can then also be presented in a waveform. So we have it over here, and where we can see the tube voltage waveform as well as the exposure rate, the dose rate waveform. So that is actually the output from the tube that we're seeing, and which gives us a very good picture, not only the numbers of it,
Yeah.
but how do we arrive at that number?
That's incredible.
Yeah, well, and it's good because we can then go back and see how did we arrive at 69.77. So we can move back and highlight on that one so we can see that waveform again when we're looking at it. So that's the waveform that we can see.
Oh.
So we've got the displays here, we've got the waveform, we've got all that. And if something odd is happening with the waveform, we may want to have a look and zoom in to see what's going on, so we can look at it in a little bit more detail.
Yeah.
So this is then what we think is the minimum requirement for a software or for an instrument to be able to provide the user. So that not only the numbers, but what's behind the numbers. Also then to change the unit of measure, simple, we just right click on it and choose something here, maybe MR per second, I think would be a good one, and MR over here. And we will then see that not only does it change here in the displays, but also in the grid where we changed it to MR and MR per second.
So all the tests that you run, are these then saved so you can always go back to them?
Yes, very good. And that's the first question that we normally get. This looks good, but can you save the data? And of course, we can save. As you see, there's a save symbol up there.
Okay.
With which we can then save this data and then recover it and reload it for viewing at a later date. And it can also be shared, so we can export the whole measurement file with all the measurements, the waveforms and everything to anybody else who has the Ocean software installed.
Wow.
So if you have a colleague and you want to share it with somebody, say that, hey, that exposure looked a bit odd. Have you seen that before? They can pull it up, the exact measurement, all the data, each individual sample of the measurement.
Yeah.
To see that, okay, well, I've seen that before. You should do, and you can cooperate and get that done. So that gives you more information about the measurement than just simply the value in the display.
Absolutely.
So I think that's kind of interesting. There's also then for a possibility to include waveforms here if there's something odd happening in a report, because there is a reporting function built in as well. That allows you then to print a report, generate a report with all the values that we've got, and if you choose also the waveforms that we have available. And for traceability, of course, also what instruments did we use, the serial number, so we have that documented for it. And before we close, we can actually then also save it as an Acrobat file. So
Okay.
It's a PDF file if you want to share that information just as an image. So, and that's also quite popular and quite interesting. So that's again something that we think is good to work with. If we make a new quick check here, this was the radiography. We can go in and see, just for simplicity's sake, how does it look if we select fluoroscopy, for instance. And it's the same screen. Basically, it's the same measurements that we do. All we look at in fluoroscopy is also the frame rate, for instance, dose per frame, and number of frames. That's what we have in that view. And of course, now we see that it's giving us an alarm because there is 0 frames, so it's not really giving us the math behind it is since we're doing a fluoro exposure. So, and if we make another quick check for mammography, we've got that as well, just to give you an idea. So if we make a new quick check, we've grouped the calibrations that we have, the configurations we have for the Piranha according to manufacturer, so it will be easier to find the target filter, the proper target filter combination.
I feel like you've thought of everything.
Well, we've tried. We've got some feedback, and we've got some, and we had it around for quite a while. So we have tried to absorb the feedback that we got into something more productive. So, for instance, if we go, Hologic is quite popular. If we go there, we can then see Dimension is the one that we're looking at a lot of the time. These are the different target filter combinations available for the dimensions.
Okay.
So it allows you to, we think it may reduce the errors sometimes.
Right.
So that you choose the right the proper calibration. And these calibrations have been then, we've arrived at those together with the manufacturers themselves. So we tweaked the formulas and the algorithms in the Piranha to arrive at a good value for
Now,
those.
I have a question. On some of the screens, this comment button lights up. Is that so you can leave yourself notes for the future, or what is that used for?
Well, it's actually then used to, so if we go back to radiography here just as an example, it's a possibility to add comments to the report.
Okay.
So, for instance, if we make an exposure of some kind, and we then look at go to a comment, and then we'll just say that, okay, we observed that the casing was cracked. Say that you made
Got
an
it.
observation, casing cracked, or also broken, whatever. So if we just make a note or a comment, whatever it might be, you can actually add pictures and images also if you like, because this is a simple word editor.
So then anyone who pulls up this report in the future will see your note?
Yes.
Okay.
So that's then saved in the measurement file itself and available in that report. So if we look at the preview of the report, we have everything here. Now we didn't select any waveforms, but we do have the comment in there.
Wow, look at that.
So that's again something that we think could be valuable when it comes to the traceability
Right.
of it. So instead of trying to remember, we've got it noted down and saved for posterity. And also, like we said, we can share the whole file, and the comments will then also be shared along the line.
Fantastic. So thank you for presenting this. Is there any other details you want to go into? Any other things our audience should know?
Well, this is then the quick check part, like we said. So
Okay.
this is the minimum that we provide our customers with when they buy a Piranha. So we think that it shouldn't be anything less. The next step is when we work with templates.
Okay.
So that's a potential time-saving tool that we include also in the Ocean software. So quick check is just the instrument part. You get the data, but what do you do with the data? That's the important thing. Now, templates can take care of that. Many of our clients used to use Excel to perform analyses and stuff like that. But and in that sense also worked with templates, but Excel templates.
Okay.
So we've built in that functionality in the Ocean software, so that would help in the workflow. So with the test procedures that are performed, they typically follow like a checklist or a set procedure when you want to collect your data and do your analysis. Do this, connect that. And so for that, we can build a template and say that imagine that you've built different templates for different purposes.
Right.
For KV testing, or for linearity testing, or reproducibility, whatever it might be. You build a library of those, and when you go in to do your testing, you can then select your template, and off you go. And this is what would happen. If you take those templates and you stick them into a favorite folder, you can then access them like this. They'll be listed. These are your typical popular and the normal ones that you do.
Right.
So when you get to site, you click on the favorite, you click on, for instance, KVP accuracy for 10K Studio. We'll look at the database later, but so it will then pull up the template in which you can build instructions for the person doing the job. Okay,
Wow.
This is the stuff that you need when you're doing your testing.
Right.
Right, just to help them remind them, okay, this is what you need to do. Then once that's clear, they start picking that out of the case, and they're getting ready. They will also have the possibility of instruction of this is how you place it, this is how you connect your probes or whatever, so that they don't have to remember that. So and also even the old hands will have a chance to do the same thing every time. That means that the data that you collect,
Right.
the chances are that will correlate to a higher degree and will then also be more valuable to you. Right, so when we're done with that and everything is connected the way it's supposed to be, the template is loaded. It's a simple procedure of just measuring the KV. We've got a set value panel here that is visible from a distance, so that you just put it to the side and operate the console and set your techniques. So when we just make sure that we have the set values done, the mass should be larger than 15, SID larger than 50 centimeters. And we start with a set KV of 50 and then start just making our exposures. So when we do that, then we set the next exposure. Along the line, the Piranha will collect and measure the KV.
Okay.
It's 49.44. The software will calculate the difference in percentage between the set value and the measured value,
Right.
and determine whether or not it's pass or fail, based on the pass-fail criteria that you've defined when you design the template. So in this case, it's plus minus 5%.
Right.
And that's the range we're looking at. And along the line, we can also then have instructions. So maybe somewhere during the test, you need to add some filters in there. You need to swivel in a copper filter for this specific test, or add a phantom layer, or I don't know what it could be. You can have those reminders pop up as you go along. This could be an example that, well, if we're doing this on a Siemens, usually there's 81. You can't set it to 80, it's 81 kV. So if we go in, we can go in and change that set value. And so it's all pass, and sometimes it also fails. So we can see if we have something else, a measurement which is not 90, if we can get a fail. There we see. You got an automatic fail immediately after the exposure is done, and that's at 90 kV. All right, that was bad. How come? Maybe because we had the wrong set value. So then we can go back, redo that exposure, and see we're now here. So we go back and redo with the correct technique setting, and we have a pass once we
Right.
the proper way. And immediately after the last exposure, there is a report generated as well. So a report which will give us the possibility to add site information where we performed this test. Also, when it was done, what data was done, what was the result of it, the summary, pass or fail. And here are then the measurements and all the documentation regarding that. Plot of how the measurements ended up, and serial number of the instrument being used for that. So it collects and gets that report done quite fast.
Right.
And documents it. And if we go to the database, we'll see that we can build a database based on the customers we visit, or the sites that we are responsible for, where each of the sites, if we go into RTI Electronics, for instance, here, we have one or more departments. Each department can have one or more rooms, and in the rooms, room 1, for instance, I have a RAD room there. We can go in and have equipment, and that equipment can be a generator and a tube. So if we go click on that, there we go, we've got a generator, and associated to that generator we have an overhead tube. And if we click on that, we'll see that we've entered and built a database with information about the tube, including serial number, manufacturer, and all that kind of stuff. Same thing with the generator. So when we make a test, say that we look at a radiography test down there, maybe, double click it, and then we'll have a test that is a multi-test template, where we in one go have HVL, and we can combine, like we said, you have a library of it, but you can combine those, so you have several in one go. HVL test, a KVP reproducibility, a KVP accuracy test, a mass linearity test, and again, all those built in with all those, and also the possibility to have and analyze questions, like a questionnaire, yes/no questions, so that we can not only connect the probes and collect data that way, but also during inspection.
And these are all questions that you guys have pre-put in there?
Well, these is our example
that
we share, just to get people started. But the idea is that customers will be able to customize this to their own specific needs,
even better,
to their own tests. So then, so they can get that done. So we've got a summary, of course, also here, pass, fail. If we look at the report, it's a preview, get a preview of the report. again, we've got site information here with the address. Now this is then utilizing the database, right?
Right.
So we've got site information, a summary, we've got information about the serial number, etc., of all the probes or the equipment being tested, and the different tests that we've performed, and also, of course, what instruments, the serial number of the instruments that we've used as well. There is a possibility also in the display, in the report, add information about calibration date of the instrument, so they can have all information in the report in one go, and just by collecting that data automatically.
Wow.
So this gives us the possibility then, when we're collecting this much data, if we look at the database here, it's relatively small, and when it comes to it, we have the possibility of doing a trend analysis on the database that we have. So if we select and say we want to do an accuracy, just look at, analyze the accuracy component of it, and maybe a tube voltage accuracy, to see how does that look? What does it look in my database? How does the individuals in my database perform with the accuracy?
Right.
The accuracy. So if we click on next, we'll then be able to limit. If we've got a large database, we can select parts of it, and like that, we can even have a specific manufacturer of generator to analyze that. So if we go to next, they will then mine the database, see that, okay, I've found that analysis here, and then we can finish and we'll get a plot of how that looks. So that means that with just by gathering the information in a structured way, we have possibility to have an overview of what it looks like.
Right.
So with this, maybe there is a chance of looking at the performance of the generator. Maybe it's degrading. Maybe there's a manufacturing fault. Maybe there's something else that we might anticipate, and thereby plan downtime for it instead of making emergency repairs.
Yeah.
We could maybe do something ahead of time.
Yeah, be preventative and stuff.
Exactly. So be ahead of the curve. So that's a little bit of the way that we think. That not only should we then have the possibility of gathering data in a structured way, we should also have a traceability. And the traceability, in our opinion, should be all the way down to the individual sample, not just the numbers behind it, but what actually generated those numbers. Because that's the waveform tells the complete story. The numbers, that's just a truncated version of that. So that's the way we see things. So that's a little bit about the Ocean software. We got, like we said, this is then the juicy part of it.
Right.
With the templates and the database and the analysis, and then of course everybody has access to the quick check part of it.
Well, thank you so much for going into detail. I do have a quick question for you. How would you best summarize RTI's overall offering of Ocean?
Well, I would say that it's not only do we offer a complete package when it comes to the hardware side, where you have competent instruments from Piranha, a range of instruments, a range of tools that can be selected and like a pick and mix, depending on your needs, over to the Cobia, which addresses other areas, and a good scatter probe. So the hardware is of course important, and we offer that as well, naturally. Has been tested by manufacturers in all continents almost, except Antarctica.
Right.
So the hardware it goes without saying, is really, really good. But what we're seeing more and more is an interest in the data.
Exactly.
That is generated. What do you do with it? And looking at a hardware or a software that can actually create a better workflow in collecting that data and analyzing the data and doing something with the measurement data that you're collecting, the numbers. So not only collecting the numbers and pushing them, but then doing something with it. So we would encourage people then to look at the broader picture of both the hardware and the software.
Fantastic. I have one last hard question for you. What is the easiest way for someone who's interested to go ahead and reach out to RTI and learn more?
Well, I would say, visit our website.
Okay.
It's rtigroup.com, And from there you have information about all the hardware and the software, and also, of course, contact information to whoever you need to reach out to.
Fantastic.
So that's what I would say.
My name's Emily. I'm here with Eric. We're at booth 101 at ICE Expo. If you are here, make sure you stop by and tell my friends hi.
Please do. Wow.